Hello there. Today we'll be doing backtracking number 78. This is letter combination of a cell phone number. In this particular problem, we are given numbers, and we're supposed to output all the possible letters. So basically, if we're given the 2, 3, and 4, so we start with an A, B, and C. Then we do a D, E, and F, and then we do a G, H, and I, and all the combinations of that. So basically, if we're given a 3 items usually. That's 3 to the n because each option has 3 more options. And then if we have a 4, then that's 4 to the n. It's possible. So we have all the letters here. I put them in before, so that makes our process a lot faster. So we're going to do a DFS call where of I, and then where we start with S. And so we're going to keep moving it forward to the next item after we're looking at the current item, and we're going to look at each item for each particular digit. We're not gonna move on to the next particular digit to get those items. So once we hit the end, I hits the end. So basically, it looks at all the digits. Then we can resolution our result appends, and we can return. So usually we would do this weird thing where we do a range, a j, and I, and length, and digits. This particular item here, basically what this does is that we can move the I forward, and for every I, we can start searching this particular item in afterwards. So we can start at, let's say, the second the item, which is 3. I start there and repeat the whole process. So what the process is for letter in letters of digits I. So basically, we'll look at that particular letter and DFS the I plus 1 and S plus letter. So the thing is, actually what happens here instead is that for letter and letter of I, we do that, but instead we do the J, and with the J we can so we look at the first character and we add, and then we look at the second character, and so on and so forth. If we run this, oh shoot, there's no DFS call yet. So DFS of we start at 0 and we build the string, and then we return the result. If we print the string here, we will see that we are doing a lot more than we actually need to. Why are we doing I plus 1 for this? Is because that doesn't make any sense either. Shouldn't it be j plus 1 so that we can call the DFS call? So let's see what happens here. So with this code, we start at I. We start at 0. Then we take the letters from all the letters from 0. So we add that to the letter. So we have A, B, and C. Then we're moving on to the second character, I plus 1, which is 1. So we do 1. And starting at 1, we do, D, E, F, right? And then we exceed the characters and we append all of them. Then we move back. That completes. We return, and we try the next item, and then we start creating more things. Let's just print it out and see what's going on. As you can see, we did double the work, and we have double D's. See here. So what we're going to do is just remove this line. Whoops. And that way we don't recall the next item, the skip. So we don't have to skip items. We're not skipping any items here, and we just do this. That way we straight up just look at the next character. Instead of printing, we don't need to print anymore. We can submit, and we should get a pretty good result. Whoops. One problem. Right. The problem is, with this problem, is that if you don't get digits, you just want to return results. You don't want to expected nothing, but whoa, what's going on? Control Z, Control Z, Control Z. So you want to just want to run the digits so that you don't get to you return an empty array. If there's no digits, then they'll just add a let's say an empty string in. You don't want that. So now we have a result. It's a little bit slower than before. Maybe we got lucky earlier, but this is a pretty good result. It's pretty simple code. And we learned about like what the first for loop does and what we're doing in the second for loop. Hope this helps you, and hope we can see more of these types of problems and solve the same problems in different ways, and we'll learn a lot more this way. Thank you very much, and I'll see you in the next one.